Hello, friend. My name is Derek Carter, and in this video, I just wanted to talk a little bit about setting up a GPU card so you can, set up your deep learning workspace. So if you're using the dev environments and the things that I talked about in the two previous videos, there are hooks in there. If you have an NVIDIA card or something acceptable like that that you want to try and use, that you can use them for, doing our class notebooks or doing our class assignments and things like that. So I talked a little bit about this before earlier. I'm not really a hardware guy. I just wanted to kind of, mention a few things. If you are thinking about getting a GPU, you do need to get NVIDIA if you want to do machine learning with it. So the AMD kinds won't work. I did mention these two sites before, so I'll just mention those again, just because I was kind of setting up. I did a personal purchase of some GPU, and I've been trying to set up some other things for getting better at video production here. So, I'd shown these sites before. Let's see here, like for example, this one, and in particular, that a little bigger there. Past it, I guess. These two graphs here, looking at the performance, the raw performance of the various NVIDIA GPUs, and also, though, if you are a little bit budget conscious, this one in particular, where it's giving it relative performance per US dollars, can be useful, so you can see which things are going to be kind of break at the price point of maybe of something that you want to get. So, I mean, right now, at least from my own budget of maybe a couple $100 to spend on things like this, I ended up with a 3060 in the line here, only 8 gigabytes, although beginning to think that maybe it would have been nice. I'll have to go maybe look again and see how much it is. The amount of memory on the card is a little bit limiting. So the amount on the GPU, of course, is different than your system memory. So you have to keep that in mind. Besides that, I mean, I guess the only, like I said, I'm not really a hardware person, but the only other kind of thing I might mention is, do keep in mind, of course, you have to have a slot in the system that you're thinking of putting it into that will fit. So that's basically a extended PCIe slot for most of these things. Right now, when I'm talking in 2025 here, and also, you do need to make certain that your power supply unit in your system is capable of driving the NVIDIA card. So, kind of the first system I was thinking about putting into was too old, so I was either going to have to update the power supply unit or do something else. So, if you're going to buy like a new system to try and put a card into, you might want to check out and keep in mind that you've got an adequate big enough power supply unit made. So most of these NVIDIA cards need, I can't remember, but they need a good amount of power in order for them to run. So, and like I mentioned before, the other link I had on those slides, that I think that if you're in like the CUDA capabilities in the 8.0, you're okay for a while. So that does include the 3000 RTX lines. The 3000, the 4000s are kind of at the 8.9, and then you got to go up to the 5000 to get these new CUDA 12 compute capabilities. So. Okay, well, with that said, if you do have access to an NVIDIA GPU for a personal system, I do recommend using Docker containers. They work really well. They help isolate getting the software you need in order to drive the GPU for compute from clobbering or interfering with other stuff that you have in your system. So, and the class resources that I have, class repository, and also the assignments have things in there for some hooks if you do have a GPU in order to configure that and use that inside the container. So nowadays, a nice thing is that the Docker and the dev containers come out of the box able to do what's known as GPU pass-through into the container, right? So it used to be kind of a hassle to get this set up to do GPU pass-through, but if you're if you're installing Docker and dev containers here in 2025, you should have it available without any extra installation to do. So let me just show you. So I've already cloned the class repository. I don't in a previous video I don't think I showed the class repository, but let me also just refer to that real quickly. Right, so that's one of the resources that you should have available. So in particular, you'll want to, this is where you get all the notebooks and the slides and the other resources. So you'll want to clone this. You'll have to clone it HTTPS. So you can't clone it with read-write privileges. So I don't allow you to make changes to this, but you can do an HTTP clone in order to pull the things down and work with them. So I've already done that before, so I'm just going to reopen my folder that I'd cloned previously for the neural networks and deep learning class that we have. So I've got that in my repos subdirectory in a folder called NNDL. Okay. So here, like the class assignments, like I've shown in previous videos, when you open this up, there's a dev container subdirectory which contains devcontainer.json and a Dockerfile. And if that's in there and you've got Docker running and you've got your remote development extensions installed, it'll detect that and offer to reopen in the container. I on purpose didn't do that because, yeah, I want to go ahead and reopen it in the container right now, but I'll just point out, no, I didn't mean the lock. So if we look at the devcontainer.json file, so I showed this in a previous video how it will install extensions for you. So another thing is some stuff is commented out here, but if you uncomment this, this is what will enable GPU pass-through when it starts running a Docker container. Okay, and then likewise in our class, the Dockerfile is where it installs conda, and then it uses the environment.yml file with this list of packages to figure out what to install using conda into the environment. For reasons that I'm not sure about, it used to be that you could install the TensorFlow and Keras packages inside of conda, but they seem to have stopped doing that. It was always a hassle. It never worked very well. So I suspect that maybe the TensorFlow people got a little bit fed up with conda. So anyway, the correct way to actually install TensorFlow or the TensorFlow with the CUDA support is to use a pip install. So for our running stuff in Docker containers, that means that we use conda to install most of the tools that we need, but we have to do a separate step to do pip installs to get the TensorFlow Keras stuff in there for this class, right? So by default, I think for most of my environments, the assignments and for the neural network and deep learning repository, it only installs TensorFlow by default, which means that you'd only be able to run TensorFlow on CPU. It wouldn't install the CUDA stuff, so you could also try and run it on GPU. So let me show you. If I reopen this my environment in a container, so since I missed that pop-up, I'm just going to go ahead and go over here to my Remote Explorer, and various ways. I'll just say to open my current folder in the container here. So since this container is already set up, it should come up right away. I've modified my Dockerfile, so you shouldn't normally get a thing to rebuild here, but I'll show that. So, but one thing I wanted to point out here is the thing I modified is I haven't actually installed TensorFlow. So, if you open up a terminal, you can try Python directly from the command line. So if I didn't have TensorFlow installed, I could always run this command. Or if I don't have usually if you have a package that's not installed that you need, you would want to use like conda. So So for example, what would be an example like PyDot is something that we might need that I probably don't have installed by default here. So usually you should probably try and prefer to install stuff using Conda. So doing pip is for stuff that's I'm not going to install. I'm not going to go through the install on this, but doing pip is for stuff that's not kind of mature enough and hasn't really made it into the Conda repository. So, but yeah, I mean, I'm going to go ahead and install TensorFlow. So let's say for some reason you had missed it, or I forgot to put this in, or you're not using our Docker containers here. So this basic one without the and cuda will install TensorFlow, but with only support for running on CPU compute. Okay, so TensorFlow is relatively big. I'll go ahead and let that run and pause and come back here once this is installed. Okay, and we're back. The TensorFlow finished installing there from the pip install command, so I should now have it available in my environment to run with. So I ended up getting version 2.1, 2.19.0 there. But yeah, so the main thing I wanted to show though is if I do have an NVIDIA card on here and I run the NVIDIA card, I need to recreate this container and enable these so that we can get the GPU pass-through. And then, of course, I should install the TensorFlow with the CUDA support so that it will be able to access GPU compute, right? So for one thing, until you have GPU pass-through, you won't be able to access the NVIDIA drivers, okay? So one of the things that I think that happens when you set up the GPU pass-through is it will get the right kind of drivers inside the container. So the NVIDIA-SMI command is kind of a basic one just to test that I can actually see the NVIDIA card and we have access to the drivers and we can see what the current load is on the GPU. So let me modify the things that I want to do here. So if I wanted to, I've got my GPU card actually on the system. If I want to get it available inside of the container, I would actually go ahead and uncomment that one in my Dockerfile, and I would go ahead and enable my GPU pass-through access by just uncommenting all of these, right? So, it kind of notices when you are playing around with these and gives you the option to rebuild. I'm going to be kind of safe here. So I'm going to go ahead and just close this container off. So I'll say File, close my remote connection. And I'm actually going to delete the container by hand and recreate it. So if I look at my Remote Explorer, I'm just going to actually blow away this container. Now, that's safe to do. So all your files, like for your assignments and things, they're not actually inside of the container. So whenever you open up a container on files like this on a host system using a dev container, the files are on your host system. So in my case, my files are over here in my repos subdirectory in the NNDL, Neural Networks and Deep Learning. That's where I clone my repository in here on my host system. So whenever it reopens a container, it remounts those inside of the containers. But so if you delete the container, it doesn't do anything to the files on the host system. So I'm just going to go ahead and remove that. And then when I reopen the folder and then ask it to reopen in a container, it should rebuild it. But now with the GPU pass-through enabled, and it will try and install the TensorFlow with the CUDA package for me. So let's go ahead and open that folder back up again for my localhost from our repos NNLD subdirectory. And this time I'll go ahead and, when it asks me, I'll go ahead and have it reopen in the container. And again, since I blew it away and I'm kind of going from scratch, this will take a little bit of a time here. Although, most of the, what do you call them, the container layers or whatever, will be cached, so they'll be on my local system, but it will have to reinstall Conda, reinstall all the Conda packages from the environment.yml, and it will reinstall the TensorFlow with the CUDA support now, since I enabled that one in my Dockerfile. So let me pause while it does that. Okay, so it's done and running here, although that was quicker than I was expecting. So let's just check real quickly. So for example, let's try the TensorFlow again, just to make certain that that we do have TensorFlow installed here. So yeah, it's in there again. So if I knew off the top of my head out, so I'll show you here. But yeah, we can figure out whether it can see the GPU or not. I'll show you that in a second. But let's also try the thing I showed you. So this will tell me that yeah, now in fact the GPU pass-through is working. So now the NVidia.SMI is set up. It has access to NVIDIA drivers presumably installed inside the container, and I can see my my 3060 NVIDIA GPU now through pass-through on the system here. There is a notebook under the utils for doing. Maybe I should rename it kind of a general. Well, just this is mainly meant in order to kind of check that you are able to access the GPU and also to give you, to kind of show you if you are running on the GPU, how much of a difference it can make over getting CPU access. So let's take a look at this here. I don't know why that's right there. Let me, oh, I didn't mean to reopen this. Yeah, so I'm running my notebook inside of VS Code here. Let me reopen that on my let me reopen that in a web browser here is kind of what I want to do. So I mean, I've shown this before. You could, one way you could go to the NoHub. You can just click on the local hosts, but you know, you'll see the problem is that you really need that token. That's really what the password kind of is. So I don't think I mentioned this before. So I mean, another thing I often do, instead of just always open up the NoHub, is I sometimes just take the time to copy that token and then use it to just set up a new password. Let's say like NVIDIA. So I don't know if there's a way to just completely remove the password, but this way that every time I can just enter in that simple password instead of reopening NoHub and finding the token that we have here. So anyway, inside I'm running my Jupyter Lab inside of my Docker container. So let's try that notebook again here. So some other things. So if you have access to the GPU, so like I already showed, you should be able to run, this is actually running this command using the inside of the Docker container from the command line. So you can see that it's still running again. There's some examples of, querying TensorFlow in order to see that it can see devices. So now we can see the CPU and GPU. Maybe I should have shown this before I enabled GPU pass-through. But so if you don't have the GPU pass-through and the CUDA support installed, you only have access to CPU devices. With the TensorFlow CUDA support installed, if I've got the driver set up, I should be able to see the GPUs in here, and then the rest of these. So here we actually run fit a model where we just use the CPU. And this will take a little bit of time to run. So in this particular case, we just make a relatively big model here with a large dense layer. And it usually takes about 20, on my system, it usually takes about 20 seconds or so for each epoch. And we do it multiple times just to take the mean. So I'll pause while this comes while this finishes. Okay, so this is still running here, but I thought I'd show a little bit of some things about trying to monitor the GPU performance, at least some basics of what you might do to just double check, that this is running on CPU or GPU. So, for example, you can open up a terminal inside your container and use a tool like top or htop. Let me see if I have htop installed. So here, this is monitoring what's going on the system, but in particular, we can mostly see that my Python process that's running in the Jupyter Notebook is running a bunch of threads here and is taking up, about half of my CPU cores that I have here, right? Might be able to easier to see that using the top tool here. So the other tool was showing the individual threads. This is just showing processes, I believe, here. So again, you can see Python working here. You can, as a crude way of monitoring the GPU, you can do that. Watch, what was it? N1. So every second it will rerun the NVidia SMI command if you do that. So this at least tells you, that I've got Python running as a compute versus a graphic. So it's doing computation using the GPU, and you can kind of see the amount of memory. So unfortunately, I just found out that, I prefer using NVtop. It actually can give you both the GPU usage and the CPU usage. It looks like it's a little bit broken right now. I'll have to look into that. So I would usually do apt. Usually you have to do like an apt update and an upgrade so that you can install like an NVtop. So yeah, maybe we just need something's changed from the previous versions of the Debian that we were using here for Conda Jupyter environment. So that used to be one of the packages available. So maybe we can find out a way to add in an additional repository to install that. I'll have to check that. So, okay, but anyway, so just let the CPU continue to run there. Okay, so we're done with the CPU compute. So like I was saying, for 5 epochs of training, each taking about 20 to 25 seconds. On average, it's taking about 130 seconds, so 2 minutes, 10 seconds there, we can see. So if you try this on GPU, so here we're going to be using it with the GPU. If you got the GPU pass-through working and everything, it'll be significantly faster. I might not even have to pause while we're running it, doing the same training on the same model, but giving it over to NVIDIA GPU for training here. Usually it takes a couple seconds, 5 or 10 per epoch here. So, I should mention that I do kind of in these notebooks, I usually turn the log level down as low as possible. So mostly you still get some kind of warning messages come out from NVIDIA and CUDA and TensorFlow. Usually you can mostly ignore those unless if you are having a problem, if your kernel is crashing or something, I usually turn those back on to get more information from CUDA and TensorFlow to figure out maybe potentially what the problem is. So yeah, these will only take 5 or 6 seconds per now, so it'll be much faster with the GPU. And we can try watching again. For example, if we look at the output from NVIDIA SMI, we'll see that the GPU is being utilized 40–50%. We can certainly do better if we tweak our model and things in order to get to actually use more percentage of the GPU. But, that's what this test is doing here. So yeah, we're only done with about 2 of these. So I'll go ahead and pause. Then we'll come back and see what the results are for the GPU. Okay, and then we're done running this on the GPU. So where before it took, 130 seconds. Now on average to do 5 epochs of training on the same model takes 38 seconds. So significant improvement. You'll see typical improvements if you're using a GPU like that. Okay, so yeah, that's it. In summary on that, I mean, for one, I really do encourage you, if you want to get serious in deep learning, to look into setting up your own deep learning environment, which would include getting some NVIDIA GPU compute that you can use at a reasonable price, or that you purchase once and can use it as needed. So I'm not a real hardware expert, but if you shop around a bit, you can get an entry level system maybe for a couple $100 right now that will have at least the CUDA 8 capabilities that you can use on your system. So and I highly encourage learning Docker and virtualization. So it's a really good way in order to set up and use GPU compute, so that you don't have to mess around with your drivers on your host system, and you can even have multiple containers with different, slightly different configurations in order to work on stuff like that. So the pass through, it used to be a bit of a hassle to get that set up, but it's coming in. It works right out of the box right now with Docker and the DevContainer things. This is on Windows. I believe the same holds for Mac OS as well. So it's part of the Docker install. I hope that's true, that it would use the GPU. Although the Mac OS environments might be a little bit more complicated, especially with the GPU kind of resources that you have in the M1. I don't know, or like the M. The Macintosh, the Apple Silicon system. So anyway, that's it for this video. I hope it's useful, and I hope to see you guys later in class.